Hello Algebra 1 students, this is Mr. Wilsey. In this video we are going to be continuing looking at how to solve linear equations. However, we're going to step up the difficulty a bit because, as you'll see, we are going to introduce multiple variables, multiple unknowns, multiple letters. We're also going to be looking at some interesting situations where equations don't have solutions or they have an infinite number of solutions. All right? So let me get my face out of the way. And let's begin. So you're taking down notes with me, please. So 10x plus 12 equals 2 times, in parentheses, 5x plus 6. Okay? So let's say we want to solve this equation. Well, the first step, as you would have learned in the last video, is to get rid of the parentheses. And we do that by distributing the 2 out front to both terms inside the parentheses. So the next line of our equation is going to be 10x plus 12 equals 2 times 5x is 10x, and then 2 times 6 is 12. Okay, we're going to be adding 12 here. Now let's try to get the x term over here to the left-hand side of the equation, and we can do that by subtracting 10x from both sides of the equation. 10x minus 10x is 0, so that goes away, leaving us with 12 on the left-hand side of the equation. And 10x minus 10x goes away, so we're left with 12 on the right-hand side of the equation. Now, notice what we found here. We found that 12 equals 12. This is a true statement, no matter what value we plug in for x, because the x goes away after we do this step here. So the unknown disappears, leaving us with a statement that is true. Now what this means is that there is an infinite number of solutions to this equation. Any value that we stick in for x will make the original equation true. Anytime in the process of solving an equation, you come up with a number equals a number, and they're the same number. So in other words, you come up with a true statement. Then the answer that you should write down is that there are an infinite number of solutions. Okay? So let's take a look at a similar type of equation. 9m minus 4 equals negative 3m plus 5 plus 12m. All right, now from the last video, we solved equations similar to this where there is an unknown appearing in multiple places on different sides of the equation. Now, in order to solve this equation for m, we need to collapse all of the m's into one m, right, so that we get m equals. So that is our ultimate goal here. So let's try doing that. Now the first thing we might do, on the right-hand side of the equation here, notice that we have a negative 3m and a positive 12m. So let's combine like terms on the right-hand side of the equation. Negative 3 plus 12 is 9. So 9 times the m, and then everything else about the equation is going to stay the same. Plus 5 on the right-hand side, 9m minus 4 on the left-hand side of the equation. Now again, let's try to get the unknown, onto the left-hand side of the equation. We do that by subtracting 9m. Now, just like in the previous equation, over here, the 9m goes away, and it also goes away over here, of course, because that was our goal right here. But what we wind up with is negative 4 on the left-hand side of the equation equals 5 on the right-hand side of the equation. Now, this statement, negative 4 equals 5, last time I checked, that was not a true statement. So, in this situation, whenever we, in the process of solving an equation, wind up with a statement that is not true, in other words, one number equals another number, but they are not the same, this means that there is no solution to the original equation. In other words, there is no number that we can stick in for m in the original equation that will ever make this a true statement. Okay? So no solution. So compare and contrast this situation here with the situation that we encountered in the last problem. All right? Okay, so let's move on to a slightly different type of problem. All right, now this is a word problem. I know that many of you hate word problems, probably as much as I do, but let's try to tackle it anyway, okay? You are ordering pizzas and sandwiches. You have a budget of $80. How many sandwiches can you buy if you buy 3 pizzas? What about 6 pizzas? Okay, now over here we have the price of 1 pizza, $10, and the price of 1 sandwich, $5. Now in this case, we actually have 2 unknowns. 2 unknowns. The first unknown is the number of pizzas. Let's represent that by, let's say the letter X. The second unknown is the number of sandwiches that we buy. Let's represent that by a different letter. Let's say Y. Now, our first goal, whenever we're tackling a word problem like this, is to write an equation. In this case, or really in any case, we're going to try to use the unknowns that we've identified as well as any numbers in the problem. We have 80, 10, 5, and we're not actually going to use the 3 and the 6 yet, but you'll see how we use them in a second. Now the way that I start to write an equation for a problem like this is to write down an equal sign, of course, and then on one side of the equal sign, usually what goes here is the total of something, right? What is the total amount of whatever you have, or whatever you're dealing with? Usually this is a good place to start. Look for a total. Well, in this case, our total is 80, right? Because we have 80 total dollars to spend on pizzas and sandwiches. So let's try to write an expression that equals 80. Now, let's think about this. If I have 1 pizza, if that's how many pizzas I buy, so X is 1, then the cost of the pizzas is going to be just $10, right? Because I just have 1 pizza. If I have 2 pizzas, the total cost of all the pizzas is going to be $20, all right? Now the way to get from the number of pizzas to the cost of all those pizzas is to simply multiply by the cost of 1 pizza, right? That will always be true. So let's use that fact to begin writing our equation. So 10 is the cost of 1 pizza times the number of pizzas. This gives the total cost of all the pizzas. Now let's do the same exact thing with the sandwiches. If we add $5 per sandwich times the number of sandwiches I buy, this represents the total cost of all the sandwiches, okay? And then this, of course, represents the total cost of everything that I bought, which has to equal $80 because that is my budget. So now we finally have an equation that models this situation. 10x plus 5y equals 80. Now, let's look at the question. How many sandwiches can you buy if you buy a certain number of pizzas? Now, what this is asking us to do is to solve this equation that we just wrote for the number of sandwiches. So solve for y. Because what this ends up doing, if we write this equation so that it says y equals something, so in other words, we've solved it for y, we have isolated y, then we can simply plug in any number for x that we want. Turns out we're going to plug in 3 and 6 here, and it will instantly tell us how many sandwiches we can buy if we bought x number of pizzas. All right, so let's try that strategy. So if I want to solve this equation for y, just like when solving equations when there's only one unknown, our goal is to get everything else to the other side of the equation to isolate y. Now, just like linear equations in one variable, in order to solve this equation for y, our first step is going to be to subtract 10x, right? Because we want to move the 10x to the right-hand side of the equation away from our y, and we have to work our way in toward the unknown. So if we subtract 10x from both sides of the equation, we have 5y equals 80 minus 10x. Now there's one more step to solve this equation for y. We have to get rid of the 5. In order to do that, we have to divide both sides by 5. So y equals 80 minus 10x divided by 5. Now if you recall, we talked about this idea of the distributive property for division. Now watch this very carefully. I'm going to break the fraction bar in two, and I'm going to attach the 5 to the denominator over on the left and on the right. Right? Do you see that? That's not too bad. Now right here, 80 divided by 5, you can simplify that fraction pretty easily. That simply reduces down to 16. And then over here, we have 10 divided by 5. That's just 2. So we're going to have a minus 2 times the x. So this equation in the box is the same exact equation we started with, except it is rewritten so that it highlights y. Now, let's use this equation to answer the question. If we have 3 pizzas, how many sandwiches can we buy? Well, I'm going to go to a new slide over here. Y equals 16 minus 2x. So what we're saying is, if x equals 3, so if we buy 3 pizzas, then x equals 3. So let's simply plug in 3 for x. Let's evaluate this equation for x equals 3, just like that. So this becomes 16 minus 6, so y equals 10. In other words, if I buy 3 pizzas, I have enough money in my budget to also buy 10 sandwiches. This is what we just found. Now, let's try this exact same situation, except with 6 pizzas. Watch what we do. Instead of 3, x is going to be equal to 6. So over here, this is going to be 6. 16 minus 2 times 6 is the same thing as 16 minus 12. 16 minus 12 is 4. So if I buy 6 pizzas, I have enough money to buy 4 sandwiches. Now this problem, which I'm going to call number 4, is very similar to the last one. In this case, we want to solve the equation for m. Alright, so I'm going to rewrite the equation out here. 4 equals 2m minus 5n. Now, we want to solve the equation for m. So we want to get everything on the same side of the equation, that is not m, over to the other side, so that m becomes isolated. Well, what is the first step we have to take in order to do that? Well, we need to move the 5n first of all. Okay, we can't move the 2 yet because we are trying to work our way in toward the unknown, and the 5n is farther away. That's my thinking, at least. So in order to move the 5n to the other side of the equation, we have to add 5n to both sides. This goes away, leaving us with 4 plus 5n on the left-hand side and 2m on the right-hand side. Now, let's divide both sides by 2, leaving us with 4 plus 5n divided by 2 equals m. Now, in this case, in the last problem, what we could have done is separate the division into 2 separate fractions. You don't always need to do that, though. In this case, I don't want to do that because I don't really want to take 5 divided by 2. Let's just leave it like this, okay? Just to show you that we can. Now, the next part of this problem asks us to find what is m when n equals each of these 3 values. So let's start with the first value, when n is negative 2. So if n equals negative 2, then let's use this equation down here. If n is negative 2, then our equation becomes 4 plus 5 times, in parentheses, always remember your parentheses, negative 2, all divided by 2 equals m. So let's begin simplifying this equation. 4 plus 5 times negative 2 is negative 10. I'm taking this divided by 2. Now 4 minus 10 is negative 6. We are dividing that by 2. Negative 6 divided by 2 is negative 3. So the value of m when n is negative 2 is negative 3. Okay? So that's how you would approach this kind of problem. Now, in order to finish the problem, you would need to now, separately from what we just did here, now we replace n with 0. Okay, this type of problem, which I'm going to label number 5, is the bane of many students' existence. Okay? What equation do you get when you solve ax minus bx equals c for x? Ax minus bx equals c. So, if we want to solve this equation for x, that means our goal is to write the equation so that x equals something. Okay? So we want to isolate the x. Here's the problem in this case. Do you see what the problem is? Well, we have x's in two different places. So how in the world do we combine the two x's into one x? That's our problem. Well, I want to give you a little thought bubble over here. Consider this. If we had an equation that looked like this, how about 5x minus 2x equals 9? How would we solve this equation for x? Well, I hope that you would see that we would combine like terms right here. 5x minus 2x is 3x, and then finally we would divide both sides by 3 to get x equals 3. Notice the form of this equation is identical to the form of this equation. A is 5, B is 2. So how can we apply what we know about how to solve equations like this? Well, watch this. Let's apply what I call the reverse distributive property. So in other words, what would have to be inside the parentheses if we pulled out the common factor from both of these terms? Well, the common factor is x. X is attached to both of these terms. So let's say there was an x out here. What would be inside the parentheses? Well, a minus b. Do you see that? If we were to distribute the x back into the parentheses, we would get a times x minus b times x, which is what we started with. Now this is going to be equal to c. Now notice what we did here. A minus b is exactly what 3 is equal to over here. 5 minus 2. Okay? So there's nothing out of the ordinary going on here. This right here is just another way to say we are combining like terms. Except we don't know what the a and the b are, right? They could represent any number they want to. Now, how do we go from here? Well, look back at our problem when we used numbers. We divided by the 3. So in this case, we are going to divide by a minus b, because that is analogous to the 3 over here. We're going to divide both sides by a minus b. So, what does x equal? Well, a minus b in parentheses cancels out on the left-hand side of the equation because we are multiplying and then we are dividing. So that cancels out, leaving us with x equals c divided by a minus b. And you don't have to put it in parentheses, although it doesn't hurt. Okay? So this is how you solve an equation like this, where the unknown x that you're trying to solve for is in multiple places. You use the reverse distributive property. Okay? All right, let's look at one last type of problem here. Now, I have a table taken from your textbook here of some formulas that you've probably seen before. Okay? And I'm going to provide these formulas to you so that you can work with them when you're doing practice problems. Now, notice each of these equations, or formulas, as the book calls them in this case, all of them have multiple letters. Okay? They have multiple letters. Sometimes, though, they might have numbers, which is okay as well. Now, an equation that has multiple letters like this, which you might have heard called a formula before. Another word for this that we use in math class for some reason is a literal equation. Okay? So all of the equations we've been solving, except for the first two, have been literal equations because they have multiple letters. Literal just means letter. Okay? They have letters. So let's say this was my situation. Let's say I have a rectangle. That's a very bad rectangle, but you get the idea. Now let's say that I know that the length is, oh, I don't know, 10 units. This is the length. Now let's say that the total perimeter of this shape is 60 units. Now I hope that you remember what perimeter means in any case. In any geometric shape, like a rectangle or a circle or a triangle, the perimeter means the total distance around the shape. Okay? Add up the lengths of all the sides, and that is the perimeter. Okay? So let's say that this whole distance here around the shape is 60. And let's say that I want to find the width. What does the width of the shape need to be in order to give me a perimeter of 60? Well, look at the formula up here. And by the way, this formula is pretty common sense, right? In order to find the perimeter of a rectangle, you just take the length, multiply it by 2, right? Because there's a length up here and there's a length down here. And then add to that 2 times the width, right? Because there's a width over here and there's a width over here. Okay? So 10 plus W plus 10 plus W. And of course, a shorthand way to say that is this formula right here. So if in this problem I want to find the width of this shape, how would I do that? Well, let's try this. Let's write out the formula. Perimeter equals 2 times the length plus 2 times the width. Now, I know what the perimeter is and I know what the length is. I want to know what is the width. So just like in the previous problems, I want to solve this equation for W so that it says W equals something. Okay? Let's do that. The first step to solving this equation for W is going to be subtract 2L from both sides of the equation. That gives us P minus 2L equals 2W. Now there's one last step. Divide both sides of the equation by 2. So we find that P minus 2L divided by 2 equals W. And again, just like in the last example, you don't need to break that fraction in 2 if you don't want to, all right? So here is our literal equation. Now, let's simply stick in the values that we have for the perimeter and the length. So P is 60, and we are going to subtract 2 times the length, which is 10, and we are going to divide all of that by 2, and this is going to be equal to our width. Well, this is 60 minus 20 divided by 2, which is 40 divided by 2, which is 20. Okay, so I'm sorry, I'm running out of room, but 20 is the width of the shape. Okay, so over here, if I wanted to, I could just bloop, bloop, 20 is the width. And of course, 10 plus 20 plus 10 plus 20 gives 60, the perimeter. All right, so that is all that I wanted to cover with solving literal equations and more complicated linear equations, including equations like this, where there's an infinite number of solutions. Oh, and by the way, I forgot to mention this. If you have an equation that has an infinite number of solutions, another word that we use for this is identity, okay? This equation is an identity if it has an infinite number of solutions. Oops. So that is it, and I hope that you are ready to begin practicing.